Stack-on connectors are specifically designed and approved for use only with stranded wire. Their application is strictly limited to stranded conductors, and they are not approved for use with solid conductors. The reason for this limitation lies in the fundamental differences between stranded and solid wire constructions and how stack-on connectors are designed to interact with them. Stranded wire consists of multiple smaller strands of wire bundled together to form a larger conductor. This construction provides flexibility, making stranded wire suitable for applications where the wire needs to be bent or moved frequently. The individual strands can move slightly relative to each other, allowing the wire to flex without breaking. Stack-on connectors are designed to grip these multiple strands, creating a secure and reliable electrical connection. The design of the connector allows it to deform slightly around the strands, ensuring a tight fit and maximizing contact surface area. This is crucial for minimizing resistance and preventing overheating at the connection point. Solid wire, on the other hand, consists of a single, solid piece of metal. It is more rigid than stranded wire and less tolerant of bending. While solid wire is suitable for certain applications, such as wiring within walls where movement is minimal, it is not compatible with stack-on connectors. When a stack-on connector is used on solid wire, a connection is often unreliable. The connector may not be able to grip the solid wire tightly enough, leading to a loose connection. This can result in increased resistance, which generates heat and can potentially cause a fire hazard. Furthermore, the rigid nature of solid wire means that it is more likely to be damaged by the crimping action of the stack-on connector. This damage can weaken the wire and make it more prone to breaking. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations. It provides detailed guidelines for wiring methods, materials, and equipment. The NEC does not specifically list every prohibited use of every connector type. Instead, it focuses on general requirements for safe and reliable electrical connections. However, the NEC emphasizes the importance of using listed or labeled equipment in accordance with the manufacturer's instructions. This means that if a stack-on connector is listed for use only with stranded wire, using it with solid wire would violate the NEC. Electrical codes and standards are in place to protect people and property from electrical hazards. These hazards include electric shock, fires, and explosions. By following the code and using the correct materials and methods, electrical installations can be made safe and reliable. Always refer to the manufacturer's instructions and the NEC when making electrical connections. This will help ensure that the connections are made properly and that the electrical system is safe. Using the wrong type of connector can have serious consequences. In addition to the risk of fire, it can also lead to equipment failure, power outages, and other problems. It is always best to err on the side of caution and use the correct connector for the application. If unsure about which connector to use, consult with a qualified electrician. There are many different types of connectors available, each designed for a specific purpose. Using the wrong connector can compromise the safety and reliability of the electrical system. Ensuring proper electrical connections involves several key considerations. Firstly, always use connectors that are listed or labeled for the specific type of wire being used. Secondly, ensure that the connector is properly sized for the wire gauge. Thirdly, make sure that the connection is tight and secure. Fourthly, protect the connection from moisture and corrosion. Fifthly, inspect the connections regularly to ensure that they are still in good condition. Electrical work can be dangerous, so it is important to take precautions to protect oneself from electric shock. Firstly, always turn off the power to the circuit before working on it. Secondly, use insulated tools. Thirdly, wear rubber gloves and eye protection. Fourthly, never work on electrical equipment in wet conditions. Fifthly, if unsure about how to do something, consult with a qualified electrician. Understanding wire gauges is also crucial in electrical work. Wire gauge refers to the diameter of the wire. The smaller the gauge number, the larger the wire diameter. Larger wires can carry more current than smaller wires. The NEC specifies the minimum wire gauge that can be used for different applications. Using a wire that is too small can cause it to overheat and potentially start a fire. The ampacity of a wire is the maximum amount of current that it can safely carry. The ampacity of a wire depends on its gauge, insulation type, and the ambient temperature. The NEC provides tables that list the ampacity of different types of wires. It is important to select a wire with an ampacity that is sufficient for the application. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When the current in a circuit exceeds the rating of the overcurrent protection device, the device will trip, interrupting the flow of current. This helps to prevent overheating and potential fires. Grounding is an important safety feature in electrical systems. A grounding wire provides a path for fault current to flow back to the source, causing the overcurrent protection device to trip. This helps to protect people from electric shock. All electrical outlets and appliances should be properly grounded. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. This helps to ensure that all metal parts are at the same potential, reducing the risk of electric shock. Electrical boxes are used to enclose and protect electrical connections. They also provide a mounting point for electrical devices, such as outlets and switches. Electrical boxes should be properly sized for the number of wires and devices that they contain. Conduit is a type of tubing that is used to protect electrical wires. It is typically made of metal or plastic. Conduit is used in locations where wires are exposed or where they need to be protected from damage. There are many different types of electrical tools available. Some common tools include wire strippers, pliers, screwdrivers, and voltage testers. It is important to use the correct tool for the job and to use the tool safely. Electrical safety is everyone's responsibility. By following safe practices and using the correct materials and methods, electrical installations can be made safe and reliable. If unsure about how to do something, consult with a qualified electrician. Remember, stack-on connectors are designed exclusively for stranded wire and should never be used with solid conductors. Always adhere to manufacturer's instructions and relevant electrical codes to ensure safety and prevent potential hazards.